Hello friends, this is Netrapchand. Welcome to my mathematics class. Let's see the today's topic. Today's topic is limits of algebraic functions all in one. This is the important one, all in one. Although I made videos or different types of videos on limits of algebraic function, this is the unique one. Here you are getting all in one, everything in one video. Alright, so let's start. The first evaluate this type of question here. So here, firstly, let me tell you the nature of question. You can see, if you see, okay, if you put directly the value of x as a 3 here, 4 times 3 minus 5, 2 times 3 plus 3, you are not going to get indeterminate form. This means you have not to simplify. You can, at that time, okay, limit of function will be equal to the value of function, okay. You can just one question I will tell you, solution here how to do. Limit x tends to 3 as x tends to 3, 4x minus 5 over 2x plus 3 is equal to, okay, now you can write on 4 times 3 minus 5 upon 2 times 3 plus 3, right, and you are getting, okay, 12 minus 5, okay, 12 minus 5 upon 6 plus 3, okay, and 12 minus 5 7 and here 9. So 7 by 9 is the limit of function. We can read like this way also, limit of function here you can write down directly also. When x tends to 3, 4x tends to 12. When x tends to 3, then 2x tends to 6. Okay, you can miss this step and you can write down also directly this one, right, 7 upon 9. Okay, because the function is not in indeterminate format. X is equal to 3, so limit of function is also equal to the value of function. 7 upon 9 is the limit of function. So this is also same type question you can do, right? You have no problem. Now in second question, evaluate. I have taken here questions which are coming in 0 upon 0 indeterminate form. If you check, okay, so 0 upon 0, 0 upon 0, here also 0 upon 0, here also you are going to get 0 upon 0, here also you are going to get 0 upon 0. So how to simplify? Firstly, okay, this means, okay, we have to simplify, then only we can find out the limit of function. Okay, so let's see here. Definitely you are going to enjoy by doing these questions. First I'm going to solve the first one. Limit as x tends to 0, 5x square plus 3x upon x. You can check directly. So you can put, okay, value of x at 0. Then what you will get? 0, 0, 0, 0 upon 0. So this is in 0 upon 0 form. So this is indeterminate form. Function is indeterminate form at x is equal to 0. This means we need to simplify. How to simplify? Let's see here. Okay, we can take common from here. Limit as x tends to 0, here x common, 5x plus 3 over x, okay. Now in next step you can write out x tends to 0, x cancel 5x plus 3. As you know, okay, here since x tends to 0, right, x tends to 0, but x is not equal to 0, so that's why, okay, right, so that's why, okay, that's why x upon x is equal to 1. Okay, so otherwise if you think, okay, here you have cancelled 0 upon 0, no, so we have not cancelled, okay, 0 upon 0, x, since x tends to 0 but x is not equal to 0, so x upon x is equal to 1. That's why you can cancel, right, them. Now as, okay, x tends to 0, 5x is gonna, okay, near to 0, so 0 plus 3 is equal to 3. So 3 is the limit of function, so easy, okay. So here also you are going to get, okay, I have done this question, here also easy, x common, same procedure you can do. Okay, here these last three questions are of the same type of, okay, now I'm going to tell this fourth one, how to simplify, simplification, okay. Now question number yours, yes, 4 number, okay, to 4. I'm going to sorry here, just, okay, a limit as x tends to 2, x squared minus 5x plus 6 over x squared minus x minus 2. You can check, okay, here you are going to get indeterminate form. Like x square 10 to 4 and 5x 4 plus 6 10, 5 10 minus 10 0 over x, when x is equal to 2, then 4 minus 2 and 2 minus 2 0. So 0 upon 0 form. Now there is no term to take common. This means we have to factorize, right? So factorize numerator as well as denominator. Definitely you are going to get one common factor. This is the method, okay, to simplify the function. As x tends to 2, here x squared minus 3x, you all know, splitting middle term, plus 6, here x squared minus 2x plus x minus 2. Okay, I also think you have a problem here. You are going to enjoy a limit as x tends to 2, x common, x minus 3 minus 2, x minus 3 over x common, x minus 2 plus, and here 1 common, x minus 2 is equal to limit x to 2. Here you are going to write on x minus 2, x minus 3 over x minus 2, and here x plus 1. Okay, x minus 3, x minus 2 common, x plus, and x minus 2 cancelled, as you know. Okay, a limit as x tends to 2, you are going to get here x minus 3, x plus 1. Right? So as you know, okay, x tends to 2 means x is not equal to 2, right? So okay, since you may write down, okay, x tends to 2 implies, okay, x minus 2 is not equal to 0, right? So that's why, okay, we can cancel, you can, right? This is the reason, right? Here now, okay, is equal to, now this is not in indeterminate form, so 2 minus 3 over 1 2, okay, sorry, here 2 plus 1, here you are going to get, okay, minus 1 upon 3. So this is the limit of function here, right? So I think, okay, you understood how to find out. So now very easily, okay, comfortably you can do the question, this question, this question. These are that simple but very important from the examination point of view for 2 marks question, right? Evaluate the limit. Okay, all right. So 2 number done. Now let's see the question number 3. Let's move into the question number 3. Question number 3. So let me tell you again, it's a question here how to do. Here also these all, okay, 1 2 3 4 5 questions I have taken. These all are important questions and very easy to find out the limit of these functions. And one more thing, these all are in indeterminate form, 0 upon 0, 0 upon 0, 0 upon 0, 0 upon 0 form. This is also function is in 0 upon 0 form, at x is equal to a, at x is equal to 2, at x is equal to 1, at x is equal to a, at x is equal to a. Now this means, okay, we have to simplify the function to find out the limit of function. So how to simplify? So always you need to rationalize here. Either, okay, from numerator side you have to rationalize, okay, here, or denominator. But in this, okay, in question number 3, all you have to rationalize from numerator side. And okay, in another way we can say you have to multiply numerator and denominator of the function by conjugate of the numerator. You know the conjugate, if we have a root a plus root b, root a plus root b, then its conjugate is root a minus root b. Okay, so I'm going to tell you the one question. If I find the limit of the one question, then easily, comfortably, you can find out the limit of all questions of 3, right? So, okay, let's move into the question number 3. Solution. Your question number 3. Question number 3 is limit. Very interesting question. Okay, and x plus a minus root 3x minus a over x minus a is equal to, now as I told you just now, we need to, right, we need to simplify by rationalizing, right? Limit as x tends to a root x plus a, let's multiply the conjugate of this root plus ये किसी ने बोला था बंद कर दे बाबू हाँ अल्लाह भाई अब डिस्टर्ब ना कर देना ना root x plus a here plus okay conjugate of this root 3x minus a over x minus a exactly as I'm writing the same way you will do root x plus a plus root 3x minus a okay so here no problem or limit as x tends to a right here now a minus b a plus b here we need to apply a square minus b square formula using that formula we can write down a square minus 3x minus a whole square over right and here x minus a and root x plus a plus root 3x minus a okay now see the next step so, okay now we have done remaining questions for practice for you and in space so I have erased so okay let's move from here right is equal to as limit x tends to a it's gonna be x plus a minus 3x because a negative sign this negative sign is going to be changed this sign right this okay becomes plus a I don't so think you have a problem at this level x minus a here write down okay same x plus a plus root 3x minus a is equal to limit as x tends to a you are going to get here minus 2x plus 2a over x minus a and here root x plus a plus root 3x minus e okay bracket close is equal to limit yeah as I have written okay exactly the same way is equal to also where I have written and this line okay where we have a drawn okay you need to see each and everything properly or limit as x tends to a here you need to take minus to common x minus a over x minus a x plus a plus 3x minus a now no problem you have so now okay as you know the x tends to a not x minus a right is equal to 0 right not equal to 0 so that's why we can cancel it okay and here limit as x tends to a minus 2 over here you will get x plus a plus root 3x minus a okay upon here now this is not an indeterminate form okay here okay this is an indeterminate form at this point okay 0 upon 0 form that's why we need to simplify but if you see here in numerator we have a constant so there is no chance to get 0 upon 0 so let's put the value of x here then value of function okay if function is not in indeterminate form then value of function is equal to limit of function okay at that time okay we get it minus 2 here we can write x tends to a this means a plus a and plus here 3a minus a you're going to get minus 2 upon root 2a plus root 2a so here I'm going to tell you minus 2 upon 2 root 2a and finally you are going to get minus 1 upon root 2a so this one is your solution right this one is a limit of function root 2a minus 1 upon root 2a is the limit of this function okay at x is equal to A. At extend, when x tends to A. Now I think you understood. Here also exactly the same method you have to apply. Here also exactly the same method. Here also same, okay. Here also same, okay, right? Try each and every question. If you get problem, you can write down in comment box. I'm ready for you. Okay. 24 times 7. There is no problem. Okay. Now, I will tell you the question number 4. 3 number I told you. The method, trick, each and everything I told you, right? For question number 3. Now, let's move into the question number 4. How to do, right? Question number 4. Okay. I need space, so I'm removing from here. Now let's see the question number 4. And before doing question number 4, we have to use, okay, we have to do, okay, we have to use, okay, here one theorem. There is a one theorem, okay. What's that, okay, theorem? Limit x raised to power n minus a raised to power n over x minus a as x tends to a is equal to n a n minus 1. Very important theorem. So in one video I have proved this theorem also, but this time, okay, we will use, okay, this theorem. Using this theorem we will find out the limit of these type of functions, right? So what's the limit? Okay, firstly try to understand, okay, so how to see, okay, theorem. Okay, see, limit as x tends to n minus a tends to n a raised to power n. Sorry, here let me read again. Limit as x tends to a x raised to power n minus a raised to power n over x minus a. Okay, then only we can write n a raised to power n. Let me, okay, write down one simple example. Okay, here, okay, we need, suppose any name, okay, I'm going to take, okay, here suppose, okay, here Ram raised to power n. Here, okay, we have Sita raised to power n. Okay, and here Ram tends to Sita. Here also we need, okay, Ram tends to Sita. Ram, see very carefully. And here Ram minus Sita. Listen to me. Then only we can apply, okay. Then what we can write down, okay, n, right? Okay, a is Sita raised to power n minus 1. Okay, n into Sita raised to power n minus 1. We can use, okay, this one. Okay, you have to memorize like this way. Here also we need, okay, then only we can write. If you Ram Sita, Ram Sita, Ram Sita, alright, and you can David Rita, David Rita, David Rita, like this way also. But we need, okay, here power n, okay, same. Then we can use this formula here, okay, right? In all these questions you can find out, yeah, this is here directly we can use formula. And here, okay, we don't have this form, so we will do some arrangement. Here also we don't have a, here also, right? We will do, okay, some arrangements. Look at here. Now using this theorem, we are going to, right? We are going to find out the limit of this function. So see, for first solution or limit as x tends to a, x raised to power 2 by 3 minus a raised to power 2 by 3 over x minus a. Directly you may write down, okay, what you can write down, 2 upon 3 a raised to power 2 upon 3 minus 1. What's the reason here? Since you may write down this theorem. Okay, here e is equal to 2 upon 3 a raised to power minus 1 upon 3. So we always try to give in positive power. So you may write down 2 over 3 a raised to power 1 by 3. So simple. I don't think now you have a problem. Okay. Alright. This one is clear. Now next question. Here. Second also I'm going to tell. Then next you can do. Second solution. The limit as x tends to a, x raised to power 5 minus a raised to power 5 over x raised to power 4 minus a raised to power 4 is equal to limit x extends to a. Here, okay, we need in this form, so let's divide by x minus a, right? Okay, numerator and denominator, let's divide by x minus a. 4 minus a raised to power 4 over x minus a. Okay, is equal to limit. So here, in limit theorem, okay, we have studied this one. Let me tell you here, we have okay theorems. Limit x tends to a, f of x over g of x. You can write down, okay. Limit as x tends to a, f of x over limit as x tends to a, g of x. If your limit x tends to a, g of x is not equal to 0, then we can use, okay, here, right? You know, right? Okay, here numerator is not equal to, so if you have this one, we can write on this one, okay? If provided limit of gx as x tends to a is not equal to 0, okay? So using this, we can write on here, uh, we can write on here limit as x tends to a, x raised to power 5 minus a raised to power 5, x minus 5 a, sorry, is here a over limit x tends to a, x raised to power 4 minus a raised to power 4, x minus a. Alright, is equal to, now you can write on just now here this theorem and here also this theorem. You now can 5 a raised to power 5 minus 1 over 4 a raised to power 4 minus 1 is equal to 5 upon 4 a raised to power 4 upon a raised to power 3 is equal to 5a upon 4. 5a upon 4. So this is the, okay, this is the limit of this function. Alright. I think you understood how to find out the solution of this question. Alright, and which one theorem we have applied here, right? Now I'm going to tell you this one also. Here how to do. We have two methods here. X tends to 64 and here x raised to power 1 by 6, you can write down minus 2. 2 means you can write down 64 raised to power 1 by 6. Because 64 raised to power 1 by 6 is equal to 2. And here cube root of x, you may write down x raised to power 1 by 3. Now 4 raised to power, you can write 64 raised to power 1 by 3. Okay, now because 64 raised to power 1 by 3 is equal to 4. Now this question is exactly in this form, and if you want to do the further steps, your next step will be this one. Okay, x raised to power 1 by 6 minus 64 raised to power 1 by 6 over x minus 64, x raised to power 1 by 3 minus 64 raised to power 1 by 3 over x minus 64. Now it's very easy. Now you can do, okay, after this, exactly, you can start this method and you can follow each and every steps of this question. You will get the answers over this. Another one also we have alternative. Alternative, I'm going to tell you. Alternative also, in alternative, no need to apply the theorem. Without applying the theorem, we can do, we can write down like this way, x here, x raised power 1 by 6, okay, minus 2. Here you may write down x raised to power x raised to 1 by 6 whole square, because x raised to power square means x, a cube root of x, minus 4 you can write on x square is equal to, this is the without using theorem, the shortcut but easy one, this x raised to power 1 by 6 minus 2, and here you can apply a square minus b square formula, a minus b, and here you may write down, okay, a, okay, plus b. Okay, now this can be cancelled out. You will have limit x raised to power, sorry, limit as x tends to 64, 1 upon x raised to 1 by 6 plus 2, and you are going to get 1 upon 64 raised to power 1 by 6 plus 2, and this will be your 2 plus 2 is equal to 1 by 4. So this one is easy without using theorem, right? So I told you the two methods. Either you can do like this way, or if you know this method, you may do like this way also, right? As you wish. Okay, any one you can apply, right? So now let's move into this type of question also clear, and this one is also little bit difficult one. That's why I have explained this question also, right? Now let's move into the question number 5. Now I'm going to resolve these questions. Now, question number 5. This is also easy question. Now I'm going to start the solution from here. Limit 5 first. Limit as x tends to a 2x minus 3x minus a and over root x minus root a. If you see this question, you will find this one in 0 upon 0 form. The function is in determinate form at x is equal to a. Alright, at x is equal to a, function is going to be 0 upon 0, right? So this is indeterminate form. This means we have to simplify. So if you see here, in numerator you will see the radical terms, in denominator also you are getting the radical expressions, right? So in this case you need to simplify, right? So how to simplify? You just rationalize, okay, from numerator as well as from denominator, okay. So in another way we can say you can multiply numerator and denominator by the conjugate of numerator as well as the conjugate of denominator. Alright. So see how to do extend as x tends to a, or here root 2x minus root 3x minus a. Easy, very easy, not so difficult. Root 2x, okay, plus root 3x minus a, okay, and here root x minus root a, okay, or root 2x plus or root 3x minus a. Here I have multiplied by the conjugate of numerator, right? By the conjugate of numerator, up and down, I mean to numerator and denominator. Now let's multiply by the conjugate of denominator, actual denominator, right? Now let's multiply conjugate. Its conjugate is root x plus root a, and here also root x plus root a. Only this thing you have to do here. If you know this one, then question is easy. Now you can, without any problem, you can. Let's see the next step. Limit as x tends to a. You're going to get here 2x minus here 3x plus a. Here I have used a square minus b square formula. A minus b, a plus b. So you can write on a square minus b square formula. And here root x plus root a. This is not going to be disturb anything. Here, okay. Now this a minus b, a plus b, use your formula. You will get here x minus a. Directly I have done. You know at this level you will not have a problem in this type of simplification. Okay. Now limit as x tends to a. If you see here 2x minus 3x means minus x plus a. Once again, negative x plus positive a plus a, right? Minus x plus a, you will get minus sign means negative sign. You need to take common. So here you will get, okay, all right. Let me tell you, okay, here. So in next step I will do root x plus root a over x minus a and root 2x plus root 3x minus a. Okay, here is minus a, right? Okay, done. Now I'm going to write here is equal to as limit x tends to a, here minus, okay, negative sign common, x minus a, here you are going to get, okay, root x plus root a over x minus a, and here root 2x plus root 3x minus a, alright, is equal to limit as x tends to a, and cancelled we will get here minus root x plus root a over root 2x plus root 3x minus a. And if you see here, if you substitute x is equal to a, you are not going to get here indeterminate form. Now simplification, you can stop the simplification. Now you can substitute at this level. You will find limit of function is equal to limit of value. You will get, okay, here, right? So what you will get the limit of function as x tends to a, you will get, okay, root x tends to root a minus, and here plus root a over root 2x, I saw here root 2a, and plus 3a minus a, and you are going to get minus to root a and root a and 2, so this also is okay. Let me write down so that you will not have any problem to understand. Is equal to minus 2 root a, you are getting a 2 root 2a to cancel, and okay, see here, and you will get here minus root a over, you can write down root 2a means root 2 into root a, okay, so root a cancel, minus 1 upon root 2. So this is the solution of your, so I mean to limit of this function, right? So minus 1 by root 2 is the square root of 2 is the minus 1 upon square root of 2 is the limit of this function. Okay, everybody. So now I don't think you have a problem. Now similarly, exactly the same method you have to use, okay, in this question as well as in this question. You will get very easily, right? Exactly the same method you have to apply. I promise you can get the answers very easily. Alright. So let's suppose only these questions I have left for you for practice. I hope you can do. You have to use only this method. Okay. Now let's move into the question number 6. Now I'm going to erase all these things. Now I'm getting a lot of spaces to write down. Now question number 6. For solution first, here extends to one thing, okay, let me tell you, limit, okay, just okay, as x tends to infinity, 1 upon x tends to 0. Here it doesn't matter, okay, any real number except to 0. If you have 0, also 0, right? So it may be minus 2, minus 3, and a real number, right? Then 1 upon x tends to 0. 2 upon x also tends to 0, right? As x tends to infinity, right? If you multiply, okay, except of a non-zero real number, okay, multiply the infinity, you are going to get, okay, infinity. Infinity times any real number except 0, infinity. Infinity plus any real number, infinity. Infinity minus any real number, infinity you are going to get. Infinity divided by any real number, infinity, right? Okay, infinity, but okay, yeah, infinity, all right. Okay, now I'm going to get it here. Limit as limit x tends to infinity, or 3x square plus 2x plus 1 over 4x square plus x plus 5. Now, okay, this is the question of indeterminate form, infinity over infinity. Uh, 3x square, when x tends to 0, 3x squared tends to infinity. So infinity, infinity. So infinity upon infinity you are going to get, right? So how to simplify? Here, okay, we have one trick. In case of the infinity, as x tends to infinity, you need to take common, right? Common, okay, you need to take the variable having highest power common from numerator as well as from denominator. So variable having highest power means x square. So x square we need to take common here. So okay, x square here, 3 plus 2 upon x plus you are going to get x square, and see here x square common, 4 plus 1 upon x plus 5 upon x square you are going to get, right? X square cancel, actually this is not exactly the infinity. Okay, we'll get here limit as x tends to infinity, 3 plus 2 upon x plus 1 upon x square, 4 plus 1 upon x plus 5 upon x square. As I told you, as x tends to infinity, your a upon x tends to 0. Here a is to 1.5 again 0, right? So directly you may write down here 3 plus, as x tends to infinity, 2 upon x tends to 0. And 1 upon x square also tends to 0. 4 plus 1 upon x tends to 0 plus 5 upon x square approaches 0, right? So your final answer is 3.4. This is the limit of this function. Okay, everybody? Now I don't think you have a problem. Exactly the same method you need to apply for remaining questions. No tricks, simple method. So for remaining questions you can apply the same method, right? So without any problem you can get the answer. Just you have to use whatever I have done in the first question. Alright. Now let me write on the equation number 7. We have still one more type of question. Okay. Let's see the question number 7. This is the last type of question in this video. Based on limit, solution, or limit as x tends to infinity, or root x plus a minus root x. If you see this one, you will get here infinity minus infinity form. Alright, so this one is in infinity minus infinity form, right? Okay, so when you will get this type of equation, you need to simplify. Here radical radical expression. Okay, so you can just multiply by the conjugate of this in numerator and denominator, root x over root x plus a plus root x. Now I don't think you have a problem. Very simple method I will use here. Limit as x tends to infinity over, now you can x plus c minus x over x plus a plus root x is equal to cancelled, and you are going to get here x tends to infinity a over root x plus a plus root x. Now this is not in indeterminate form, right? Okay, now we can write a upon, as x tends to infinity, here you will get x plus a also infinity, plus this is also infinity. Listen to me here, right? If you use, okay, when x tends to infinity, x tends to infinity, infinity plus a also infinity, right? Root of infinity also infinity. If you think how we have written it directly, so you can see, if you think, okay, as x tends to infinity, here okay, it becomes okay, infinity plus a, right? Infinity plus a also infinity, square root of infinity also infinity we write, alright? So that's why I've written here directly infinity, here also infinity, and infinity plus infinity also infinity. So a upon infinity is equal to 0. Now we have a problem, right? Now you understood 0 is the limit of this function. Okay everybody, so exactly you can do, I have done this question, you can do this one also, right? Exactly same here also you are going to get 0, here also you are going to get 0 answer, right? Limit of exactly the same method you need to apply, right? You will get here also 0 0 0. Okay, let me tell you, this may be the little bit different questions. Okay, let's see. Okay, question number your 3 number, I'm going to 4 number. Okay, solution 4 number, or limit as x tends to infinity root 3x minus root x minus 5. Okay, and this is also infinity minus infinity form. Limit as x tends to infinity, just same method you need to apply, and minus root x minus 5, and your root 3x minus, okay, plus x minus 5 whole over root 3x plus root x minus 5. You're going to get here limit as x tends to infinity. You will get here 3x minus x plus 5. I've used a square minus b square formula, and here root 3x plus root x minus 5. No problem, right? So after this, I'm going to tell here, you're getting, okay, limit is equal to as limit as x tends to infinity. You are going to get here 2x plus 5 over here root 3x plus root x minus 5. If you see this one, okay, again infinity plus 5 infinity plus over infinity plus infinity infinity. So you are going to get here infinity upon infinity form, as okay 2x plus 5 tends to infinity, and root 3x also infinity, root x minus 5 tends to also infinity, as x tends to infinity. So what you will get will be infinity over infinity plus infinity, means infinity over infinity. So infinity upon infinity form. Alright. So this means, okay, now only one option you have, right? Whatever simplification we have done, now you can just take common, right? Just okay, you need to take, okay, variable, okay, common. So because here x, okay, x common, 2 plus 5 upon x. Here x, you can't take x common, you can, okay, root x common. So you will get, okay, root 3 plus, you will get here 1 minus 5 upon x. So let me tell you, okay, here, because of your root x minus 5 mean here x common 1 minus 5 upon x. So meaning of this one, root x into root 1 minus 5x, right? If you have a problem how we have it taken, you can see this one, right? If you see this one, each and every your doubt will be clear, right? Okay, now let's simplify limit as x tends to infinity. You are going to get x upon root x. X upon root x means root x. X upon root x means root x, right? You can check by law of indices. Okay, here root x, x upon root x, and here 2 plus 5 upon x. You will get here 3 plus root 1 minus 5 upon x. Now, okay, this is not an indeterminate form. Now you can use, okay, as x tends to 0, this infinity, 2 plus 0 over root 3 plus over here 1 minus 0. You are going to get this one infinity, infinity times to infinity over root 3 plus 1, a real number. Infinity divided by root 3 plus 1 means infinity, right? So infinity, you are going to get here infinity as a limit of this function for number. So listen to me one more thing, okay? Whenever you get the infinity, you can say the limit of function does not guess, okay? If you get, okay, infinity, because, okay, infinity, you are not going to get, okay, right? So this can't be your a limit means okay which going to obstacle after some time, okay, which can be obstacle for something later. So this is not going to be infinity, so this you can write down. If you get okay infinity, you can write down okay which does not exist, so therefore limit of function you can write does not exist, you can write limit of. If you get infinity, you can say limit of function does not exist, okay. Infinity you may get, okay, this shows okay limit of function at x tends to infinity does not exist, okay. So clear, this type of fun you may get, okay. This one I told, right, this is a little bit different. And now let's see the next question. Next question is this one. I guess you can do this, the easy one, okay, right? And just you need to take okay root x and just apply the same method, okay. Let it be the same. Okay, let me tell you okay this question also. Don't worry. Okay, x tends to infinity. Here root x. Here root x minus x minus a, okay, or this is also in indeterminate form. You're going to limit x tends to infinity. Now okay, for this I'm using a shortened method, okay, x minus x plus a over your root x plus root x minus a. Now you, I think you understood, okay, I have multiplied up and down by the conjugates of this term as I have done in earlier questions, right? Earlier question exactly the same thing I have done here. A limit x tends to infinity or root x times a, x is con, okay, or they can be cancelled, or root x plus root x minus a. Alright, now still this is an indeterminate form because infinity upon infinity, now only one you can do. Now from here root x common in numerator, in denominator, so limit as x tends to infinity root x times a over, right, and root x common here 1 plus you will get here 1 minus a upon x. I think you understood, right? Because x minus a means root x 1 minus a upon x, and this can be written like this way 1 minus a upon x. Now okay, alright, if you write down okay this one in this form, then we can take root x common, right? So now I think you understood how we have taken root x common. No, root x okay cancel, and they can be cancelled, and we will get okay a 1 plus root 1 minus a upon x. Now you have a problem, it's very easy. So you are going to get okay a over 1 plus root 1 minus 0, as we know the a as x tends to infinity, a upon x tends to 0, right? So you are going to get okay a upon 1 plus 1 is equal to a upon 2. So this is the limit of this function. Alright, this one 5 number. Now I'm going to tell you the last one question. Okay, 6 number. Okay, question number 6. Limit x tends to infinity or root x minus a. This is the little bit different question. Root bx is equal to, the same method you need to apply. As x tends to infinity, or can, or root x minus a minus root bx, and here root x minus a plus root bx, okay, or root x minus a plus root bx. Here you are going to get a limit as x tends to infinity x minus a. Here you are going to get okay bx. I have applied okay a square minus b square formula over root x minus a plus root bx, right? And the limit as x tends to infinity x comma 1 minus b minus a over here root x minus a plus root bx. Here listen to me, everybody, okay, value of b matters. If value of b is 1, you will get here x times 0 means only constant term you will get in numerator, right? It will not get, okay, if b is not equal to 0, then you will not get constant term, okay. You will have variable also in numerator. This means, okay, value of b is going to change the answers of this question, limit of this question now, right? If b is equal to 1, then so case first I have taken, then your, okay, limit x tends to infinity, x, okay, x 1 minus b minus a o root x minus a plus root bx, right, becomes your limit as x tends to infinity, x over 1 minus 1 minus a upon root x minus a plus root 1 times x. Okay, so this is going to be, okay, here going to be 0 here, this one, okay, 0 minus a upon root x minus a plus root x. Now I'm going to tell you here, okay, is equal to, now this is not in indeterminate form, okay, limit as x tends to infinity, you are going to get, okay, minus a over root x minus a plus root x. So is equal to limit as, okay, now you can apply minus a over, this is going to be infinity, infinity plus infinity, right? As you know, minus a upon infinity, this also, and minus, okay, this is going to be 0, right? So one answer we got, okay, 0, right? So I don't think you have no problem, right? Now second case, okay, let me take, if b is not equal to 1, right? If b is not equal to 1, then what will happen, right? If b is not equal to 1, x is not going to be removed from the numerator. Limit as x tends to infinity, x 1 minus b minus a over root x minus a plus root bx is equal to, you will have limit x tends to infinity, then you can do only one thing, x common 1 minus b minus a over x, over here root x common, and here, okay, 1 minus a upon x, I told you already, a upon x within root, and plus here b, okay, is equal to your x upon root x, as I have done already in one question, as x tends to infinity, x upon root x 1 minus b minus a over x, this is a b, okay, and here 1 minus a over x plus root b. And now you are going to get here, what you will get here, yes, okay, here infinity. Now this is not an indeterminate form, already I have told you this equation. Here infinity, as x tends to 0, root infinity also infinity, and 1 minus b is going to be 0 because a upon infinity is 0, here root and 1 minus a upon infinity means 0, okay, and plus, yeah, this, okay, if you have any confusion, you may write down like this way also. This is going to be 0, and okay, root b. So you have, okay, infinity over 1 plus root b. This is going to be your infinity. So in this case, you can say the limit of function does not exist. Okay, two, okay, limit of functions we are getting here, two values, two limit of functions we are getting. Okay, one in two conditions. If b is equal to 1, then we are getting, okay, 0 as a limit of function. If b is not equal to 1, then we are getting infinity, which does not exist. So if b is not equal to 1, then limit of function at as x tends to infinity does not exist, right? When x tends to infinity, it does not exist. Okay, clear? So finally you may write down, okay, therefore, okay, limit as x tends to infinity, x minus a minus root bx, right? Okay, is equal to, I'm writing here, so you may get with 0 if b is equal to 1, infinity if b is not equal to 1. Like this way you may write down, right? And here you may write down limit of function does not exist. Okay, this infinity, for infinity. Okay, this is the important type of question and little bit difficult also in this video. Okay, so almost all types of algebraic functions I have done here, different questions I have taken. So I accept, okay, video is little bit lengthy, okay, and but you need to see very carefully, and this video is going to be very helpful and useful to you. All right, thank you very much for watching this video. If you think it's very important and it's very useful to your contemporary or friends, then please share and tell them to subscribe, because all you are getting, okay, more and more videos in coming days. Okay, bye bye.